So, hello, I'm Prathamesh Itnove, and as per it, I got a project of food waste prediction app. So, summary of the project is that the local food waste management is this is an AIML project designed to tackle food waste, connecting surplus food providers driven through platforms. I built using Python, SQL, and Streamlit. The system allows providers to list surplus foods received to claim it while leveraging EDA to uncover trends like wastage, hostage, claim success rate, and provide receiver activity. The project this project integrates a structured SQL database to store and manage food listing claims, and user details, enabling efficient query and real-time insight via 15 plus analytics SQL queries. It is theme-based web app, Streamlit-based web app. So, problem statement of the project is that the food waste is a significant issue with many household and restaurants discarding surplus food while numerous people struggle with food insecurity. This project aims to develop a local food wastage management system where restaurant can restaurant individual can list surplus food, NGOs or individual can in need can claim the food. SQL stores the available food details and location. A streamlined app enables interaction, filtering, include and operation and visualization. So let's begin with the code. First of all, I have imported libraries, dataset loading, and all. Moving to data visualization, I've mainly made the three types of chart, I mean 15 EDA with each of three types. The first one is a bar chart which tells us total food availability per city. Second is a pie chart which tells the distribution of food types into vegetarian, non-vegetarian, and vegan. The third one is a stacked bar. This is this tells us the food availability by meat type, breakfast, lunch, dinner, and snacks. The fourth one is a line chart. This tells the trend of the food listing over time, daily, weekly, monthly. The fifth one is the heat map. Food availability versus expiry date. This is to identify urgent distribution needs. The next one is the bar chart again, and this is now the five charts which I will explain is from the point of view of provider and receiver analysis. The first one is a bar chart, number of providers per city. Second one is pie chart, distribution of providers type like restaurant, groceries, supermarkets. Next is a bar chart, which tells the number of receivers per city. Next, pie chart, which tells the number of receiver per city. Sorry, not number of receivers. Distribution of receiver types like NGOs, community center, individuals, etc. So next is scatter plot, which tells us the provider activity number of listing versus claim success rate. Moving on to the next one, this tells us the claim and trains. The first one is number of claims per city. Next is pie chart claims status distribution pending, complete or cancelled. Next one is the line chart, which tells trends of claim over time, daily, weekly, monthly. Bar chart, which tells top five most claimed food items. And next is last one, the box plot, which tells the quantity of the food claimed per receiver to identify outliers. To tell you, I use the d- data set, which is the claim data dot csv, food data listing dot food listing data dot csv, providers data dot csv, and receivers data dot csv. This is handling outliers, loading data set, connecting, drop, all the necessary changes. This is the SQL operation done. Loading the data set, connecting to the database, and because of it, two databases are formed. There is food donation DB and food wastage DB. Loaded the data set. I've done the 15 queries operation, as you can see here. One. So now I will be explaining it the model one. To tell you about the model one, the purpose of the model one is that it is a random forest model which predicts whether the food listing will be claimed or will not be claimed based on listing characteristics, data. The second is data which that is used 10 sample food listing with feature like quality, city in like Mumbai, Delhi, Bangalore, Chennai, and providers like type like restaurant and individuals. The model uses five input features like quantity, city indicators for various cities, and restaurant indicator. The random forest classifier with 100 distribution tree is chosen for its robustness and ability to handle mixed data types. Data is split into 80-20 for training, testing, and the model learns pattern from the training set to predict claim likelihood. The model performance is measured using accuracy score and detailed classification metrics. The limitation, speaking about the limitation of the model, small data sets means like 10 samples may result may not generate well. Means the result will not generate well. Larger data set would improve reliability. I've only made us two models. Moving on to the second model. For first model is the model performance by class. And moving on to second model. This is the model is like regression model. The the purpose of this model is that this is gradient boosted regression predicts that exact quality of the food that will claim food listing rather than whether will be claimed or not. It uses quantity claimed as a continuous target, making the regression problem instead of classification. Gradient boosting regressor builds 100 sequential decision trees where each tree learns from previous tree's mistake. Uses learning rate 0.1 for gradually learning, max step 3 to prevent outfitting and sequential tree building for improved accuracy. Same five input features as before, like in model 1. The model learns the relationship between listing characteristics and actual claim quantity that from historical data patterns. The regression output is unlike classification binaries output. This model predicts continuous values like 12.45 items will be claimed, etc. The business value, speaking about business value, the more precise than the binary classification. Knowing 8.5 out of 10 items will be claimed is more actionable than just will be claimed. Then this is for deployment of the project. Now I would like to deploy the project. This is streamlined model that I have made. Local food management system, predicting the quantity of the food to be claimed. The first one here, we have to enter the quantity of the food listed. Like I'm putting 5. Then we have to select the city, like Bangalore. Select the provider type, individual, or we would say like restaurant. Then we predict quantity to be claimed. Based on the result that we got is based on the input, the predicted quantity of food will be claimed is 4.58 units. Going on to the next 6. If we put it like Mumbai, and here if we put like restaurant, the output will be that will be get that the predicted food quantity is 4.5.41 units. So that's all. That's the model that I have made. Thank you so much.